everyone, my name is Aulia Yasmin and my student number is 2023-32081 and welcome to today's video. In this video, we will be diving into the detail of a network configuration for a company with multiple branch and headquarters. The company is connected to the internet via a central hub known as the cloud, and we'll be discussing how the network is designed, configured, and connected. You will see a full explanation of how the network is structured, the configuration of its office location, and how communication between these branches happens seamlessly through dynamic routing protocols. As you can see, this is the overall topology of the network. It consists of 4 main routers, one for each location, headquarters, and 3 branches, branch A, branch B, and branch C. These routers are interconnected using a serial connection, forming a one or wide area network, and the cloud at the top represents the internet of external connectivity, which is accessible through router HQ. Let's start with the headquarters network. The headquarters acts as the central hub of the company network. It's connected to 3 local networks. It's using a different subnet. The first one is 192.168.10.0/26 for the first network. And for the second network, 192.168.10.64/26. And for the third network, 192.168.10.128/26. Each of these networks has PCs connected to them, so each network can hold up to 62 devices, thanks to subnet OS or /26. Now, each of this network is connected via switches. The first switch connects to PC1 and PC2. For example, let's say PC1 in the first network has an IP address of 192.168.10.2/26 with a subnet mask of 255.255.255.192 and the default gateway set to 192.168.10.1, which is the router IP for the subnet. And this is how PC1 can send traffic to other devices outside its local network by forwarding the traffic to the default gateway to the router. Similarly, the second switch connects to more PCs in the second network with IP addresses ranging from 192.168.10.66 to 192.168.10.126. Now, in the server section, we have DNS server, web server, mail server, and file server, all placed on the 192.168.10.192/29 subnet. These subnets allow for smaller range of devices, ideal for the server. For example, the DNS server has the IP address of 192.168.10.194 and use 192.168.10.193 as the default gateway. Lastly, router HQ is the central point of the cloud connection. The router connects to the internet through cloud, providing internet access for all branches and devices within the network. Moving on to branch A, as you can see, branch A is connected to router HQ through a point-to-point connection on the 192.168.1.224/30 network, the 192.168.20.0/27 and 192.168.20.32/27 subnet are used for local network here, with each subnet holding up to 30 devices. Let's break this down. Switch 1 connected to PC1 and PC2. For example, PC1 might have the IP address 192.168.20.2/27 with 192.168.20.1 as the default gateway. The gateway is typically the router's interface that connects to the subnet. Switch 2 is connected to another pair of PCs in the 192.168.20.32/27 subnet, which is follow the same pattern, PCs getting IP from the usable range and using 192.168.20.33 as the default gateway. Branch A router connects to router HQ using a /30 subnet, and all these local network are dynamically routed using AEGRP, allowing seamless communication between this network in HQ and the branch. Next, let's talk about branch B. Similar to branch A, branch B has two local network, 192.168.30.0/26 and 192.168.30.64/26. The router here connects to router A using the 192.168.1.228/30 network. Switch 1 connect to PC1 and PC2 in the 192.168.30.0/26 subnet with 192.168.30.1 as the default gateway. For these devices, switch 2 connects another set of PCs in the 192.168.30.64/26 subnet using 192.168.30.65 as the default gateway. Once again, we're using EIGRP to dynamically route between the subnet in router B, and this allow efficient communication between branch B and router HQ. Finally, let's move to branch C. This branch used to subnet 192.168.40.0/27 and 192.168.40.32/27. The router at branch C connects to the router B using the 192.168.1232/30 network. Switch 1 is connected to PC1 and PC2 in the 192.168.40.0/27 subnet with 192.168.40.1 as the default gateway. Switch 2 connect to more PCs in the 192.168.40.32/27 subnet using 192.168.40.33 as the default gateway. And just like branch A and B, EIGRP is configured to dynamically route traffic between router C and router HQ, allowing for seamless communication across all branches. As we move to the cloud, we see how everything is connected to the internet. The cloud here represents the ESP or internet connection. The router HQ is connected to the cloud, which provides internet access to the entire network. This allows devices in the headquarters and branch to access external research and services. All branches are router rely on router headquarters to route traffic between their local networks and the outside world, ensuring that all devices can access the internet and maintain connectivity. Okay, that was my explanation of the network configuration for the headquarters and all branches. I've used dynamic routing protocol like AEGRP allows for seamless communication between all branches and the headquarters. The cloud server as the critical point of connection to the internet, and everything is carefully set up using proper subnetting to ensure efficient IP address allocation. I hope this video helps you understand how the network is designed, how it functions, and how everything is interconnected. If you have any question and need further clarification, feel free to leave a comment below. Thanks for watching.